Welcome and good morning to our Unit 9, Lesson 6 notes. Today we are solving inequalities involving absolute value. If at any time in this video I'm going too fast, remember you can pause the video, you can re-watch some part of it, and you can take this at your own pace. So we are continuing in our unit of inequalities. We started out by graphing them and then solving them in different ways, and now we're going to use inequalities with absolute value. Now, you'll remember from earlier this year that we talked about absolute value as being a number's distance from zero. So an absolute value is basically how far a number is from zero. And when talking about absolute value, I like to look at a number line because that helps me visualize what I'm talking about. I get a picture of it. So for example, if we have the absolute value of some number is equal to 3, well then I know that that number is 3 units away from 0. The first one that I like to think of is 3 itself. 3 is 3 units away from 0. 1, 2, 3. That's that same distance. Now, if I want to go not only to the right, but I can also go to the left 3 units, and that gives me -3. So there are two numbers that satisfy the equation. Either x equals -3 or x equals 3. So since they both work, that gives us an and. Isn't that great? So the absolute value of 3 is 0. Sorry, the absolute value of 3 is 3, but also the absolute value of -3 is 3. So we can, what's in our absolute value symbols can be positive and it can be negative. So let's look at the absolute value with a less than. If our absolute value is less than 3, that means our number is closer to 0 than 3. So 2 is closer to 0, 1 is closer to 0 than 3, but so is -1, because -1 has an absolute value of 1. In fact, any number within this whole range, these are all closer to 0 than 3 is. They all have an absolute value of less than 3. So we could say x is less than 3. We're going to say x is greater than -3. If we look at all of our positive numbers, any positive number that's less than 3, that's closer to 0 than 3 is. And if we look at our negative numbers, any negative number that's greater than 3, well, that's going to be closer to 0 than -3 is. So we can write this as an and. X is greater than -3 and x is less than 3. If you like to put them together like I do, that's -3 is less than, not 0, -3 is less than, x is less than 3. This also works. So that's if you have an inequality that's less than, or an absolute value that's less than 3. What if you have an absolute value that's greater than 3? Well, then we'll want to find some numbers that are farther away than 3 is. 4 is farther away, and so is 5, and so is 6, and literally everything that's bigger than 3 has an absolute value that's also bigger than 3. So we can have any number, x is greater than 3. But you can also find negative numbers that are farther away from 0 than -3 is. That's going to be anything going in this direction. So as long as it's farther from 0 than -3, well, those are going to be numbers where x is less than -3. It's like the absolute value of -5, for example. Absolute value of -5 is 5, and that's bigger than 3, so that's cool. Now because this guy split, he's an or statement. So remember, when we looked at absolute values, we needed to take into account positive numbers as well as negative numbers. This is why when we're solving an inequality with absolute value, remember absolute value, distance from 0, we are going to split it up into two cases. We're going to take what's in our absolute value and we're going to make it positive. This will find all of our positive numbers. We're going to take what's in our absolute value, we'll also make it negative. This will help us find our negative solutions. Now that's all great and theoretical, and that's kind of a lot of information, but what does this mean for me? How can we actually put this into practice? Well, guys, I'm so glad you asked. You guys are so good at asking good questions. I love it. Keep it up. So remember, we're going to split it into positive and negative. Let's look. What is in our absolute value symbol here? We have an x minus 7. The absolute value of their difference is less than 4. So we're going to take what's in our absolute value. We're going to make it positive and negative. So we have x minus 7 is less than 4. Let's go ahead and take that guy. We'll bring him down to our workspace. And to make him positive, we'll put a little plus sign in front. To make him negative, we'll put a minus sign in front. Now this positive, you don't really need to have a positive. That's like saying times 1 doesn't really do anything. So there we go. That's a much cleaner guy. To solve him, we add 7 to both sides. So x is less than 11. On this other side, this negative, well, let's divide by -1 on both sides to get rid of him. Oh, look, we're dividing by a negative number. What happens when we do that? When we divide by a negative number, we remember to flip the sign around, to flip the inequality symbol. So our less than becomes a greater than. Greater than -4, x minus 7. So we'll add 7 to both sides. We get x is greater than 3. We can combine these into one inequality by saying, well, 3 is less than x, so 3 is less than x is less than 11. As long as we have a number between 3 and 11, that will make our inequality true. Go ahead and pause the video and pick a number in this range and check to see if this is true. You can pick any number as long as it is between 3 and 11. So to graph this, what I'm going to do is I'm going to graph each side. So first, let's graph x is less than 11. We're going to put an 11 here. To graph x is less than 11, that's an open circle, and that's going to go this way. To graph x is greater than 3, we're going to start at 3. That's another open circle, but x is greater than 3 goes this way. And this is why I like to write and inequalities together as one statement, because you have your x between 3 and 11. Good. So that's how to solve an inequality with absolute value. You'll notice that this one in particular has less than 4. If you have inequalities involving an absolute value and a less than symbol, those will always be and statements. Just like up here we have 3 is less than x and x is less than 11. Now let's look at one that's a greater than symbol. So we have the absolute value of 5x is greater than 40. Now what are we going to do? Oh, let's split it up into a positive and into a negative. Okay, so we're going to take our inequality, we're going to take our absolute value, and we're going to, whoops, wrong tool. We're going to take our absolute value, and we're going to make what's in that positive, and we're going to make it negative. So absolute value of 5x is greater than 40. So on one side, we want it to be positive. On the other side, we want it to be negative. So we've got a positive statement, we've got a negative statement. Now to solve our positive guy, we can just divide by 5 on both sides, giving us that x is greater than or equal to 8. Cool. Our negative side, we're going to do something very similar, yet very different. We're going to divide by -5, but check it out. We're dividing by a negative number again. So we need to flip our symbol around. That'll give us less than or equal to -8. And then the negative 5's cancel out. X is less than or equal to -8. Now this guy is going to be an or sentence. Either x is greater than 8 or it's less than -8 or equal to. So to graph this guy, we're going to have to split him up. If we have 0 in the middle, got 8, -8 on this side. To graph x is greater than or equal to 8. That's a closed circle going greater than. X is less than or equal to -8. That's another closed circle going less than. So because we have this or, our graph is split, going two different directions. Now, inequalities involving an absolute value that are greater than something, those will always be or statements. So if you have less than, that's and, greater than is or. Now that's all fine and dandy, Miss Van Dyke. I remember that if we have an absolute value, we need to set what's in our absolute value as positive and negative, and then we solve those two inequalities. So now that I understand that process, how is this going to benefit me in real life? What a great question you guys have. We are going to talk about tolerance. And we're going to look at what tolerance is, and then we'll take it to the basketball court, and then we'll take it to the golf store. So tolerance is another way to say what is close enough. What's my fudge factor? How much wiggle room do I have? Inequalities involving an absolute value are often used to indicate tolerance. That's the amount of error or uncertainty that's allowed when taking measurements. Basically, how much can I mess up and still be close enough? Well, let's go ahead and find out. So first, we have our first situation where Danny's basketball score is within 6 points of his single scoring game average of 32. What we're going to do is we're going to figure out what our possible scores are by subtracting what we expect him to get, taking the absolute value of that difference, and setting it within our tolerance. Within, here, that within indicates that that's our tolerance, that's 6 points. He's going to have plus or minus 6 points of his average. His average is 32. We expect him to get 32 points in a game. Now, his score range is going to be within that plus or minus 6. So those are the possible scores he could have. Let's go ahead and plug in the information we know. Well, we don't know his possible scores. We know his expected is 32. We'll take the absolute value of their difference, set it less than or equal to our tolerance interval, which is 6. So here we go. Now that we've got an absolute value inequality, let's go ahead and split it up into positive and negative. So we have x minus 32 is less than or equal to 6, and negative x minus 32 is less than or equal to 6. Now let's solve them. On this side, we'll add 32 to both sides. These 32s will cancel out. How nice is that? These 32s will cancel out. So we get x is less than or equal to 38. So Danny scored up to 38 points. Great effort, Danny. Now on our negative side, we're going to divide by -1 on both sides. And since we're dividing by a negative number, we have to flip our inequality symbol around, giving us greater than -6. And then these guys will cancel out, negative over negative. So we get x minus 32 is greater than or equal to -36. We'll add 32 to both sides. And then minus 32 plus 32 will cancel out, giving us x is greater than or equal to 26. Let's go ahead and graph our inequalities and see what we get. Now when graphing word problems like these, I like to put my expected value. We expect Danny to get 32. I like to put that right in the middle. And we know he goes all the way up to 38, all the way down to 26. Now if we did this right, then the tolerance, the within 6, if we add 6 and we minus 6 from his expected value, we should get our bounds. So 32 plus 6 is 38. 32 minus 6 is 26. Awesome. So now let's go ahead and graph our inequalities and make sure we lined up with that. So for our first one, x is less than or equal to 38. That gives us a closed circle at 38, and we're going down. And then for our second one, x is greater than or equal to 26, gives us another closed circle at 26, going up. And sure enough, there we go. That's our interval. So who's playing this? Danny? Whatever Danny's score was, it's somewhere within this range. Think you got it? Go ahead and take our key idea of the absolute value of our possible outcomes minus what we expect, take the absolute value of that difference, and then set that less than or equal to our tolerance. Go ahead and try to find out Gabe's situation. Okay, here we go. So we have at the end of his shift at the golf supply store, Gabe must balance his drawer and be within $4 of the expected balance. Within 4, that's our tolerance. If his expected balance is $207.30, we expect him to have that much. That's our expected. What are the acceptable balances for his drawer? Acceptable, possible, that's what we're trying to find out. So we don't know what our acceptable ones are. That's what we're looking for. We'll make that x minus his expected. He's expected to have $207.3. We're going to take that absolute value, set it less than or equal to our tolerance, which is 4. Now we have an absolute value and an inequality. So let's go ahead and split it up into positive and negative. So we have x minus 207.3 is less than 4. Sorry, it's less than or equal to 4. Or we take that whole thing and we say negative x minus 207.3 is less than or equal to 4. Here we go. So to solve this guy, we're just going to add 207.3 to each side. And these guys will cancel out on this side. That's going to be really nice, giving us x is less than or equal to 211.3. That is, Gabe can have up to $211.30 when he checks out for the day. Now let's solve our negative side. Our first step on our negative side is we're going to divide by -1. And remember, when we divide by a negative number, we need to do what to our inequality symbol? That's right. We need to flip our inequality symbol around. So because we divide by a negative number, we're flipping that inequality symbol. 4 divided by -1 is -4. Here, the negatives cancel out. So we have x minus 207.3 is greater than or equal to -4. Then we're going to add 207.3 to both sides, and that will cancel out by. Then finally we're left that x is greater than or equal to 203.3. So Gabe needs to have at least $203.30 left in his register. Let's go ahead and graph our options. Again, we're going to start our graph in the middle with what we expect. We can go up to 211.3 and down to 203.3. Let's graph each of our inequalities. We have x is less than or equal to 211.3. So that's going to start at 211 and go down. Or x is greater than 203.3. We start at 203 and go up. And there you go. There's our tolerance interval. So again, we start out with this formula right here. We take what we're looking for, our possibilities. To find our possibilities, we're going to subtract what we expect, take the absolute value of that difference, and set it less than or equal to our tolerance. We did that up here too. All because when we deal with absolute value, we split it into positive and negative numbers, because you can have positive numbers within that distance and you can have negative numbers within that distance. Enjoy your homework.